Welcome, fellow travelers, to a journey that will carry us across billions of light years through the cosmic tapestry woven with threads of stardust, gravity, and time itself. We stand at the precipice of the cosmos, ready to delve into its mysteries and unravel its secrets. Our vessel on this voyage is the indomitable human spirit, our insatiable curiosity, our boundless imagination, and our relentless pursuit of knowledge. We will traverse the vast cosmic ocean, charting its celestial landmarks and exploring its uncharted depths. Prepare to be awestruck by stunning visuals, to be challenged by profound scientific insights, and to be captivated by tales of discovery and exploration. From the birth of stars in fiery nebulas to the dance of galaxies across the cosmos, we will witness the universe's grand symphony unfold before our very eyes. Fasten your seatbelts and adjust your thinking caps, for we are about to embark on an unforgettable adventure. An exploration of the cosmos that will ignite our imaginations and leave us forever changed by the sheer grandeur of it all. Imagine, if you will, a time before time, a place before space, a point of unimaginable density and temperature. This, my friends, is where our story begins. The birth of the universe, the event we call the Big Bang. About 13.8 billion years ago, our universe burst into existence from a state of unimaginable compression. It wasn't an explosion in the traditional sense, not a detonation in a pre-existing void, but rather an expansion, a stretching of space and time itself. From this infinitely small point, the universe expanded and cooled, its energy transforming into the fundamental forces and particles that govern our cosmos. Think of it as an incredibly hot, dense soup of energy cooling and separating into its constituent ingredients. In those first fleeting fractions of a second, the very fabric of reality was woven, setting in motion the chain of events that would ultimately lead to the formation of stars, galaxies, and, yes, even us. When we gaze up at the night sky, we are greeted by a breathtaking tapestry of stars. But these stars are not randomly scattered throughout space. They are grouped together in vast gravitationally bound systems called galaxies. Galaxies are the fundamental building blocks of the large-scale structure of the universe, islands of stars, gas, dust, and dark matter adrift in the vast cosmic ocean. Our own Milky Way galaxy, a barred spiral galaxy, is just one of trillions estimated to exist in the observable universe. These cosmic islands come in a variety of shapes and sizes, from majestic spirals with elegant arms to massive elliptical galaxies with smooth, featureless profiles. Each galaxy is a unique laboratory, a testament to the complex interplay of gravity, gas physics, and stellar evolution. But how did these magnificent structures arise from the primordial soup of the early universe? To answer that question, we must journey back billions of years, to a time when the universe was a much smaller and hotter place. In the cosmic tapestry, woven with threads of gas, dust, and starlight, exist objects of immense power and mystery, black holes. These celestial entities are born from the death throes of massive stars, their cores collapsing under the relentless crush of their own gravity. Imagine, if you will, the power of a star, millions of times the mass of our sun, compressed into a point smaller than an atom. This is the singularity at the heart of a black hole, a region where the laws of physics as we know them break down. Around this singularity lies an invisible boundary, the event horizon. This is the point of no return where gravity's pull is so strong that nothing, not even light, can escape its grasp. Cross this threshold, and you're on a one-way trip to oblivion. Black holes are cosmic enigmas, challenging our understanding of the universe. Yet they are also powerful engines of cosmic evolution, shaping the galaxies they inhabit and influencing the very fabric of space-time itself. In the early 20th century, the prevailing view of the universe was one of static eternity, a cosmic stage where galaxies hung suspended in an unchanging void. This view was about to be shattered, revolutionizing our understanding of the cosmos and our place within it. Enter Edwin Hubble, an astronomer armed with a powerful telescope and an insatiable curiosity about the distant reaches of space. By meticulously observing distant galaxies, Hubble noticed something peculiar. Their light was stretched, shifted towards the red end of the spectrum. This redshift, Hubble realized, was not due to the galaxy's motion through space, but rather to the expansion of space itself. Like dots on an inflating balloon, galaxies were moving apart from each other, not because they were moving through space, but because the space between them was stretching. This groundbreaking discovery, announced in 1929, forever changed our view of the cosmos. The universe was not static and unchanging, but rather dynamic and expanding. A realization with profound implications for our understanding of its origin and fate. For centuries, humanity gazed upon the night sky, wondering if other worlds, like our own Earth, might exist beyond the familiar planets of our solar system. Were we alone in the vast expanse of the cosmos, or did other planets, perhaps even teeming with life, orbit distant stars? In the latter half of the 20th century, this age-old question began to shift from the realm of speculation to the realm of scientific inquiry. Astronomers, armed with increasingly sophisticated telescopes and techniques, embarked on a quest to discover planets beyond our solar system, worlds known as exoplanets. The early years of exoplanet hunting were met with skepticism and challenges. Detecting these faint, distant worlds, often dwarfed by the blinding light of their host stars, seemed like an impossible task. Yet, driven by the allure of discovery and the profound implications of finding another Earth, astronomers persevered. Their efforts would ultimately be rewarded, ushering in a new era of astronomical exploration and revolutionizing our understanding of planetary systems and the potential for life beyond our pale blue dot. Across the vast cosmic canvas, stars are not randomly scattered but congregate in enormous swirling galaxies. These galaxies, like the Milky Way and Andromeda, are vast collections of stars, gas, dust, and dark matter bound together by gravity. Each galaxy can contain billions or even trillions of stars, each at a different stage in its life cycle. The Milky Way, our home galaxy, is a barred spiral galaxy, with its stars arranged in a central bar and spiral arms. Andromeda, our closest galactic neighbor, is also a spiral galaxy, and it is on a collision course with the Milky Way, set to merge in about 4.5 billion years. The sheer scale and beauty of these galaxies are a testament to the grandeur of the universe. And within these galaxies we find the birthplace of stars, stellar nurseries. These regions, also known as star-forming regions, are where new stars are born from the remnants of previous generations of stars. The Eagle Nebula, for example, is a famous stellar nursery, home to the iconic pillars of creation. These towering columns of gas and dust are incubators for new stars, where the conditions are just right for star formation to occur. These are immense clouds of gas and dust, often light years across, where the raw materials for stars are found in abundance. Nebulae, as these clouds are called, come in various shapes and sizes, and they are often illuminated by the light of nearby stars, creating stunning cosmic vistas. The Orion Nebula, for instance, is a bright and well-known star-forming region visible to the naked eye from Earth. Within these nebulae, the gas and dust are in constant motion, driven by the forces of gravity and the energy from nearby stars. Imagine, if you will, a cosmic kitchen where gravity is the master chef. In this kitchen, the ingredients for stars, hydrogen, helium, and a sprinkle of heavier elements, are mixed and kneaded together by the relentless force of gravity. This process is not a quick one. It can take millions of years for a star to form from the raw materials in a nebula, but over time gravity pulls the gas and dust together, creating dense regions within the nebula where star formation can begin. It relentlessly draws in the ingredients, hydrogen, helium, and a sprinkle of heavier elements, and begins to knead them together. As the gas and dust are pulled together, they begin to heat up, and the pressure within these regions increases. This process continues until the conditions are just right for nuclear fusion to begin. The formation of a star is a delicate balance between the inward pull of gravity and the outward pressure from the heat and radiation generated by nuclear fusion. These clouds, also known as nebulae, are not static entities. They are dynamic and ever-evolving, constantly changing shape and structure as the forces within them interact. The interplay of gravity, magnetic fields, and the energy from nearby stars creates a complex and ever-changing environment within the nebula. Over time, these interactions can lead to the formation of new stars, as regions within the nebula become dense enough for nuclear fusion to begin. They are dynamic and ever-evolving, sculpted by the interplay of gravity, magnetic fields, and the energy from nearby stars. The magnetic fields within a nebula can influence the movement of gas and dust, creating regions of higher density where star formation is more likely to occur. The energy from nearby stars can also play a role, as the radiation and stellar winds from these stars can compress the gas and dust, triggering the formation of new stars. As gravity pulls the gas and dust inward, the cloud begins to fragment, forming dense clumps of matter. These clumps, known as protostars, are the embryonic stage of a star's life. Within these protostars, the pressure and temperature continue to rise as more and more material is drawn in. The process of star formation is a slow and gradual one, taking millions of years to complete. But eventually the conditions within the protostar become just right for nuclear fusion to begin. These clumps, called protostars, are the embryonic stage of a star's life. As the protostar continues to draw in material, its core becomes hotter and denser. The pressure within the core increases, and the temperature rises to millions of degrees. This is the critical stage in the formation of a star, as the conditions within the core must be just right for nuclear fusion to begin. Once fusion starts, the protostar becomes a true star shining brightly in the cosmos. As more and more matter is drawn in, the protostar's core heats up under the immense pressure. The temperature within the core can reach millions of degrees, creating the conditions necessary for nuclear fusion to begin. This process is the key to a star's life, as it is the fusion of hydrogen atoms into helium that provides the energy for the star to shine. The more material the protostar draws in, the hotter and denser its core becomes, until finally, nuclear fusion begins. Temperatures soar to millions of degrees, but this is just the preheating phase of the cosmic oven. The real action begins when nuclear fusion starts, as the hydrogen atoms in the core of the protostar are forced together to form helium. This process releases an incredible amount of energy, which radiates outward from the core, providing the light and heat that we see from stars. The preheating phase is a critical stage in the formation of a star, as it sets the stage for the fusion process to begin. The lifeblood of a star, the very essence of its existence, is nuclear fusion. This process, which occurs in the core of the star, is what provides the energy for the star to shine. The fusion of hydrogen atoms into helium releases an incredible amount of energy, which radiates outward from the core, providing the light and heat that we see from stars. This process is the key to a star's life, as it is the fusion of hydrogen atoms into helium that provides the energy for the star to shine. Deep within the core of a protostar, where temperatures and pressures reach unimaginable levels, hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse together. This process, known as nuclear fusion, is what provides the energy for the star to shine. The fusion of hydrogen atoms into helium releases an incredible amount of energy, which radiates outward from the core, providing the light and heat that we see from stars. This process is the key to a star's life, as it is the fusion of hydrogen atoms into helium that provides the energy for the star to shine. This fusion process, the merging of atomic nuclei, releases an incredible amount of energy. This energy, in the form of radiation, pushes outward from the core of the star, providing the light and heat that we see from stars. The fusion of hydrogen atoms into helium is the key to a star's life, as it is this process that provides the energy for the star to shine. The energy released by nuclear fusion is what allows stars to shine brightly in the cosmos, providing the light and heat that we see from stars. This energy, in the form of radiation, pushes outward, counteracting the inward pull of gravity. The balance between the outward pressure from the radiation and the inward pull of gravity is what allows a star to maintain its shape and stability. This delicate balance is what allows stars to shine brightly in the cosmos, providing the light and heat that we see from stars. The energy released by nuclear fusion is what allows stars to shine brightly in the cosmos, providing the light and heat that we see from stars. And so, a delicate balance is struck. The outward pressure from fusion holds the star up against its own immense gravity. This balance is what allows stars to maintain their shape and stability, providing the light and heat that we see from stars. The energy released by nuclear fusion is what allows stars to shine brightly in the cosmos, providing the light and heat that we see from stars. The balance between the outward pressure from the radiation and the inward pull of gravity is what allows a star to maintain its shape and stability, providing the light and heat that we see from stars. For centuries, astronomers have diligently studied the cosmos, mapping the positions and movements of stars and galaxies. These celestial cartographers have used their observations to build a comprehensive understanding of the universe, from the smallest asteroids to the largest galaxy clusters. The night sky, once a source of myth and legend, has become a vast, intricate map of cosmic phenomena. With each new discovery, our knowledge of the universe has expanded, revealing the complex interplay of forces that govern the motion of celestial bodies. And as our telescopes grew larger and more powerful, we began to notice something peculiar, something that challenged our understanding of the universe. These powerful instruments allowed us to peer deeper into space, capturing the faint light from distant galaxies and revealing details that were previously hidden from view. With each new generation of telescopes, our ability to observe the cosmos improved, leading to discoveries that reshaped our understanding of the universe. The galaxies we observed were not moving as they should have been, given the amount of visible matter they contained. According to the laws of gravity, the motion of stars and galaxies should be determined by the amount of matter we can see. However, the observed motions of these celestial bodies did not match our predictions. This discrepancy suggested that there was something missing from our understanding of the universe, something that was exerting a gravitational influence but was not visible to our telescopes. Stars in the outer regions of spiral galaxies were moving much faster than expected, defying the laws of gravity as we understood them. According to our calculations, the outer stars should have been moving more slowly, as the gravitational pull from the visible matter in the galaxy should have been weaker at those distances. Instead, these stars were moving at speeds that suggested the presence of additional, unseen mass. It was as if some invisible hand was tugging at these stars, accelerating them to speeds that could not be explained by the visible matter alone. This mysterious force seemed to be acting throughout the galaxy, affecting the motion of stars and gas clouds in ways that defied our understanding of gravity. The presence of this unseen mass was inferred from its gravitational effects, leading astronomers to search for an explanation. This mysterious discrepancy between the observed motion of galaxies and the amount of visible matter became known as the missing mass problem. The missing mass problem posed a significant challenge to our understanding of the universe, as it suggested that there was a substantial amount of matter that we could not see. This unseen matter was exerting a gravitational influence on the visible matter, affecting the motion of stars and galaxies in ways that could not be explained by the known laws of physics. Astronomers were faced with a profound question: what could possibly account for this missing mass? The search for an answer led to a variety of theories and hypotheses, as scientists sought to explain the observed discrepancies. Some proposed that there might be large amounts of unseen ordinary matter, such as faint stars or black holes, that were contributing to the gravitational effects. Others suggested that our understanding of gravity itself might need to be revised. The answer, it turned out, lay not in some new form of visible matter, but in something far more elusive and enigmatic: dark matter. Dark matter is a form of matter that does not interact with light or other electromagnetic radiation, making it invisible to our telescopes. Despite its invisibility, dark matter exerts a gravitational influence on the visible matter in the universe, affecting the motion of stars and galaxies. Dark matter, as its name suggests, does not interact with light, making it invisible to our telescopes. This means that we cannot see dark matter directly, but we can infer its presence from its gravitational effects. The existence of dark matter was first proposed in the 1930s by the Swiss astronomer Fritz Zwicky, who observed that the motion of galaxies in clusters could not be explained by the visible matter alone. It does not emit, absorb, or reflect light, rendering it completely transparent to our traditional methods of astronomical observation. This makes dark matter incredibly difficult to detect, as it does not produce any of the signals that we typically use to observe celestial objects. Instead, we must rely on indirect methods, such as observing the gravitational effects of dark matter on visible matter, to study its properties. Yet, despite its elusive nature, we know dark matter exists because of its gravitational influence on the visible universe. The presence of dark matter can be inferred from the way it affects the motion of stars and galaxies, as well as from its influence on the large-scale structure of the universe. For example, the rotation curves of spiral galaxies, which plot the rotational velocity of stars as a function of their distance from the galactic center, provide strong evidence for the existence of dark matter. It acts as a kind of cosmic scaffolding, providing the extra gravity needed to hold galaxies together and explain their observed rotation curves. Without the additional gravitational pull from dark matter, the outer stars and spiral galaxies would not be able to maintain their high velocities, and the galaxies would fly apart. Dark matter also plays a crucial role in the formation and evolution of galaxies, as its gravitational influence helps to pull gas and stars together to form the structures we observe today. Without dark matter, galaxies would simply fly apart, their stars scattered across the vastness of space. The presence of dark matter is essential for the stability of galaxies, as it provides the additional gravitational force needed to hold them together. This invisible matter makes up about 27% of the total mass energy content of the universe, far outweighing the visible matter, which accounts for only about 5%. The remaining 68% is made up of an even more mysterious component known as dark energy, which is driving the accelerated expansion of the universe. Nestled within the Milky Way galaxy, a swirling spiral of hundreds of billions of stars, lies our own cosmic neighborhood, the solar system. This celestial family, governed by the gravitational pull of our sun, is a captivating collection of planets, moons, asteroids, and comets, each with its own unique story to tell. At the heart of it all lies the Sun, a yellow dwarf star that has been steadily shining for about 4.6 billion years. Its immense gravity holds the solar system together, dictating the orbits of all the objects within its domain. The Sun's energy, generated by nuclear fusion in its core, bathes the solar system in light and warmth, making life on Earth possible. Orbiting the Sun are the 8 planets, each a world unto itself. The inner planets, Mercury, Venus, Earth, and Mars, are rocky terrestrial planets with solid surfaces and relatively thin atmospheres. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants, massive worlds composed primarily of hydrogen and helium. Beyond the planets lies the Kuiper Belt, a region populated by icy bodies, remnants from the early solar system. And even farther out, forming a vast spherical halo around the Sun, is the Oort cloud, thought to be the source of long-period comets that grace our skies on rare occasions. Section 2. The Inner Planets, Rocky Worlds. From the moment our ancestors first gazed upon the night sky, we've been driven by an insatiable curiosity to unravel the cosmos's mysteries. But it wasn't until the mid-20th century that humanity finally broke free from Earth's gravitational shackles and ventured into the cosmic ocean. On July 20, 1969, the world held its breath as Neil Armstrong took that momentous first step onto the lunar surface. One small step for man, one giant leap for mankind. These words echoed across the globe, marking a pivotal moment in human history. The Apollo missions weren't just about planting a flag on the moon, they were a testament to our collective ingenuity, our relentless pursuit of knowledge, and our unyielding desire to push the boundaries of what's possible. The images of Earth, a fragile blue sphere suspended in the vast blackness of space, profoundly impacted our perspective. For the first time, we saw our home planet not as a collection of nations and continents, but as a single, interconnected world. It underscored the shared destiny of all humankind and the importance of preserving our pale blue dot. The legacy of Apollo extends far beyond the lunar surface. It ignited a passion for space exploration that continues to burn brightly today. The technologies developed during the Apollo era have revolutionized countless fields, from telecommunications to medicine, leaving an indelible mark on our modern world. For millennia, humans have gazed up at the night sky, awestruck by the sheer immensity of the cosmos. The stars, planets, and galaxies that fill the night sky have always been a source of wonder and inspiration. Ancient civilizations built monuments aligned with celestial bodies, and myths and legends were born from the patterns they saw in the stars. The night sky has been a canvas for human imagination, a place where gods, heroes, and monsters lived among the stars. As our understanding of the universe has grown, so too has our curiosity about what lies beyond our own world. In the face of such vastness, it's only natural to wonder, are we alone in this grand cosmic theater? The question of whether we are alone in the universe has been a driving force behind much of our scientific exploration. From the earliest astronomers who charted the movements of the planets to the modern scientists who send probes to the far reaches of our solar system, the search for extraterrestrial life has been a central theme in our quest to understand the cosmos. The idea that there might be other beings out there, looking up at their own night sky and wondering the same thing, is both humbling and exhilarating. The search for extraterrestrial life, once relegated to the realm of science fiction, has become a legitimate scientific endeavor, captivating our imaginations and driving us to explore the universe with renewed purpose. Advances in technology have allowed us to peer deeper into space than ever before, and the discovery of exoplanets, planets orbiting stars outside our solar system, has opened up new possibilities for finding life beyond Earth. Missions like the Kepler Space Telescope have identified thousands of potential exoplanets, some of which may have conditions suitable for life. The search for extraterrestrial life is no longer just a dream, it is a scientific pursuit with real potential for discovery. The sheer number of stars and galaxies in the observable universe suggests that the ingredients for life, as we know it, may be common throughout the cosmos. With billions of stars in our Milky Way galaxy alone, and each of those stars potentially hosting planets, the chances of finding life elsewhere seem increasingly plausible. The discovery of extremophiles, organisms that can survive in extreme conditions on Earth, has further expanded our understanding of where life might exist. If life can thrive in the boiling hot springs of Yellowstone or the acidic waters of Rio Tinto, it might also survive in the harsh environments of other planets and moons. Billions of stars in our Milky Way galaxy alone are orbited by planets, and many of these exoplanets are located within their star's habitable zone, where temperatures could allow liquid water to exist on their surfaces. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions are just right for liquid water to exist. Water is essential for life as we know it, and finding planets within this zone is a key focus of the search for extraterrestrial life. The discovery of water on moons like Europa and Enceladus has also raised the possibility that life might exist in subsurface oceans, protected from the harsh conditions of space. And many of these exoplanets are located within their star's habitable zone, where temperatures could allow liquid water to exist on their surfaces. The search for life beyond Earth is not just about finding planets with the right conditions. It is also about understanding the processes that lead to the emergence of life. Scientists are studying the chemical and physical conditions that might allow life to develop, and they are looking for signs of life in the form of biosignatures, chemical indicators that life might be present. The discovery of methane on Mars, for example, has sparked interest because methane can be produced by biological processes. But the question of life beyond Earth goes far deeper than simply finding a planet with the right conditions. It involves understanding the complex interplay of factors that can lead to the emergence of life. Life, as we understand it, is a complex and delicate phenomenon, arising from an intricate interplay of chemical reactions and environmental factors. The study of astrobiology, the science of life in the universe, seeks to understand these processes and to identify the conditions that might allow life to exist elsewhere. This involves studying the origins of life on Earth, as well as the potential for life on other planets and moons. Life, as we understand it, is a complex and delicate phenomenon, arising from an intricate interplay of chemical reactions and environmental factors. The origins of life on Earth are still not fully understood, and scientists are exploring a variety of theories about how life might have begun. Some researchers believe that life may have originated in deep-sea hydrothermal vents, where mineral-rich water provides the energy needed for chemical reactions. Others suggest that life might have started in shallow pools of water, where the concentration of organic molecules could have led to the formation of the first living cells. Understanding the origins of life on Earth can provide clues about how life might arise elsewhere in the universe. While we've made remarkable strides in understanding the building blocks of life, the spark that ignites these ingredients into living organisms remains one of science's greatest mysteries. The transition from non-living to living matter is a fundamental question that scientists are still trying to answer. Researchers are studying the conditions that might allow life to emerge, and they are conducting experiments to recreate these conditions in the laboratory. By understanding the processes that lead to the formation of life, we can better understand the potential for life to exist elsewhere in the universe. The spark that ignites these ingredients into living organisms remains one of science's greatest mysteries. Despite the challenges, the search for extraterrestrial life is a pursuit that speaks to our deepest curiosities about our place in the cosmos. The discovery of life beyond Earth would have profound implications for our understanding of the universe and our place in it. It would challenge our assumptions about the uniqueness of life on Earth and open up new possibilities for the existence of other civilizations. The search for extraterrestrial life is not just about finding other beings, it is about understanding the nature of life itself and our place in the cosmos. Despite the challenges, the search for extraterrestrial life is a pursuit that speaks to our deepest curiosities about our place in the cosmos. The search for life beyond Earth is a journey that takes us to the farthest reaches of our solar system and beyond. It involves the use of advanced technology such as space telescopes and robotic probes to explore distant worlds and gather data. It also involves the collaboration of scientists from a variety of disciplines, including astronomy, biology, chemistry, and geology. Together, they are working to answer one of the most profound questions of all. Are we alone in the universe? If we were to find evidence of life beyond Earth, even in its simplest form, it would profoundly alter our understanding of life's origins and our place in the universe. The discovery of even the simplest forms of life, such as microbes, would have profound implications for our understanding of the universe. It would suggest that life is not unique to Earth, and that the conditions for life might be more common than we previously thought. It would also raise new questions about the potential for more complex life forms to exist elsewhere in the universe. The search for extraterrestrial life is a journey of discovery that has the potential to change our understanding of the cosmos and our place in it. It would profoundly alter our understanding of life's origins and our place in the universe. The search for extraterrestrial life is a quest that speaks to our deepest sense of curiosity and wonder. It is a journey that takes us to the farthest reaches of our imagination and challenges us to think about our place in the cosmos. Whether we find life beyond Earth or not, the search itself is a testament to our desire to understand the universe and our place in it. It is a journey that will continue to inspire and captivate us for generations to come. Imagine, if you will, a time when the universe was young, a mere infant in cosmic terms, just 380,000 years old. Back then, the universe was a seething cauldron of intense heat and energy, a cosmic soup of fundamental particles and radiation. It was a time before stars, before galaxies, before even the atoms that make up our bodies had formed. From this primordial inferno emerged a faint afterglow, a relic of the Big Bang itself, known as the cosmic microwave background radiation, or CMB for short. This faint microwave radiation, discovered serendipitously in 1964, permeates every corner of the observable universe, carrying with it the secrets of the universe's earliest moments. The discovery of the CMB was a watershed moment in cosmology, providing the most compelling evidence yet for the Big Bang theory. You see, the CMB's existence had been predicted by the theory, and its characteristics, such as its temperature and uniformity, matched the predictions with astonishing accuracy. Think of the CMB as a baby picture of the universe, a snapshot taken when the universe was just a fraction of its current age. By studying this ancient radiation, we can peer back in time and unravel the mysteries of the universe's birth and evolution. We've spent the last 12 chapters exploring the vastness of our universe. From the smallest particles to the largest cosmic structures, we've delved into the mysteries that define our existence. We've marveled at the birth of stars, the formation of planets, and the intricate dance of galaxies. We've journeyed through billions of light years and across eons of time, witnessing the grandeur and complexity of the cosmos. From the birth of stars to the dance of galaxies, we've journeyed through billions of light years and across eons of time. But what if I told you that our universe, as mind-bogglingly immense as it is, might not be the only one? What if the cosmos we know is just a single chapter in an infinite library of universes, each with its own unique story to tell? But what if I told you that our universe, as mind-bogglingly immense as it is, might not be the only one? This is where we step into the realm of cosmology that borders on science fiction, a realm where the very fabric of reality seems to multiply before our eyes. Imagine a cosmic landscape where every possibility, every conceivable outcome exists simultaneously in a vast, interconnected web of realities. This is where we step into the realm of cosmology that borders on science fiction, a realm where the very fabric of reality seems to multiply before our eyes. This is the realm of the multiverse. The idea itself is not new. It has been a philosophical debate for centuries, a thought experiment tossed around by thinkers across time and cultures. From ancient mythologies to modern science fiction, the concept of multiple universes has captured the human imagination. This is the realm of the multiverse. The idea itself is not new. It has been a philosophical debate for centuries, a thought experiment tossed around by thinkers across time and cultures. But what was once confined to the fringes of scientific inquiry has gained traction in recent decades, fueled by observations in quantum mechanics and theoretical physics. The multiverse theory suggests that our universe is just one of many, each with its own set of physical laws and constants. The idea itself is not new. It has been a philosophical debate for centuries, a thought experiment tossed around by thinkers across time and cultures. It has been a philosophical debate for centuries, a thought experiment tossed around by thinkers across time and cultures. From the ancient Greeks who pondered the existence of other worlds, To the medieval scholars who speculated about the nature of the cosmos, the idea of multiple universes has been a recurring theme in human thought. Even in modern times, the concept has found its way into popular culture, inspiring countless books, movies, and television shows. But what was once confined to the fringes of scientific inquiry has gained traction in recent decades, fueled by observations in quantum mechanics and theoretical physics. The strange and counterintuitive nature of quantum mechanics has led scientists to propose that our universe may be just one of many, each with its own unique set of physical laws and constants. These ideas challenge our understanding of reality and open up new possibilities for the nature of existence. You see, some interpretations of these theories suggest that the universe we observe, the one we call home, may be just one of an infinite number of universes, each with its own set of physical laws and constants. Imagine, if you will, a cosmic lottery, where every possible outcome of the Big Bang, every permutation of physical laws, is played out in a separate, self-contained universe. In one universe, the laws of physics might be similar to our own, while in another, they could be radically different. Imagine, if you will, a cosmic lottery, where every possible outcome of the Big Bang, every permutation of physical laws, is played out in a separate, self-contained universe. This means that there could be universes where stars never formed, where gravity works in reverse, or where time flows backward. The possibilities are truly endless, and the implications are profound. If the multiverse theory is correct, it means that our universe is just one of many, each with its own unique history and destiny. Every permutation of physical laws is played out in a separate, self-contained universe. This means that there could be universes where stars never formed, where gravity works in reverse, or where time flows backward. The possibilities are truly endless, and the implications are profound. If the multiverse theory is correct, it means that our universe is just one of many, each with its own unique history and destiny. It forces us to reconsider our place in the grand scheme of, well, everything is played out in a separate, self-contained universe. That's the essence of the multiverse theory, a concept so grand, so awe-inspiring, that it forces us to reconsider our place in the grand scheme of, well, everything. It challenges our understanding of reality and opens up new possibilities for the nature of existence. It invites us to imagine a cosmos that is far more complex and mysterious than we ever thought possible. That's the essence of the multiverse theory, a concept so grand, so awe-inspiring, that it forces us to reconsider our place in the grand scheme of, well, everything. It challenges our understanding of reality and opens up new possibilities for the nature of existence. It invites us to imagine a cosmos that is far more complex and mysterious than we ever thought possible. As we continue to explore the mysteries of the universe, we may one day uncover evidence that confirms the existence of the multiverse, forever changing our understanding of reality and our place within it. For as long as humans have walked the earth, we've gazed up at the night sky in wonder and awe. The stars, like celestial pinpoints of light against the velvet canvas of space, have served as a source of inspiration, mythology, and scientific inquiry for millennia. Our ancestors, lacking the sophisticated instruments of modern astronomy, relied on their naked eyes and keen observational skills to track the movements of celestial objects. They noticed patterns in the stars, constellations that became the characters of their myths and legends, stories passed down through generations, connecting them to the cosmos. These early sky watchers were the first astronomers charting the heavens, predicting celestial events, and weaving narratives around the cosmic tapestry that unfolded above them. From the ancient Egyptians who aligned their pyramids with the stars, to the Babylonians who developed sophisticated systems of mathematics to track the movements of planets, every civilization has developed its own unique relationship with the cosmos. Their observations, though rudimentary by today's standards, laid the foundation for the scientific revolution that would transform our understanding of the universe. It's a journey that spans cultures, continents, and millennia, a testament to human curiosity and our enduring quest to comprehend the cosmos and our place within it. Section 2. Ancient Astronomers. Throughout our journey, we've walked in the footsteps of giants, pioneers who dared to challenge the known and unravel the mysteries of the cosmos. These individuals were not just scientists, they were visionaries who looked beyond the horizon and saw possibilities where others saw only darkness. They were the ones who asked the questions that no one else dared to ask, and in doing so, they opened up new realms of knowledge and understanding. These weren't just people with telescopes. They were dreamers, thinkers, and rebels who reshaped our understanding of the universe and our place within it. They were the ones who looked up at the night sky and saw not just stars, but a vast, uncharted territory waiting to be explored. They were the ones who dared to dream of other worlds, other galaxies, and other dimensions. From the ancient philosophers who first pondered the nature of the heavens to the modern astrophysicists who grapple with the mind-bending implications of quantum mechanics and relativity, the quest to understand the universe has been a journey of intellectual exploration and discovery. The ancient Greeks, for example, were among the first to develop theories about the nature of the cosmos. They believed that the universe was a harmonious, ordered system governed by mathematical principles. This idea laid the groundwork for the development of modern science. The quest to understand the universe has been a relay race of insight and discovery. Each generation of scientists has built upon the work of those who came before, adding new layers of knowledge and understanding. This process of cumulative discovery has led to some of the most profound insights in the history of science. For example, the work of Copernicus, Galileo, and Kepler laid the foundation for Newton's laws of motion and universal gravitation, which in turn paved the way for Einstein's theory of relativity. In this chapter, we'll celebrate some of these towering figures, individuals who've left an indelible mark on the tapestry of astronomical knowledge. Galileo Galilei, for example, was one of the first to use a telescope to observe the heavens, and his discoveries revolutionized our understanding of the solar system. Isaac Newton's laws of motion and universal gravitation provided a framework for understanding the physical universe. Albert Einstein's theory of relativity fundamentally changed our understanding of space and time. Individuals who've left an indelible mark on the tapestry of astronomical knowledge. These scientists were not just observers, they were thinkers who developed new theories and models to explain their observations. They were the ones who took the raw data and turned it into meaningful insights. They were the ones who saw patterns where others saw only chaos. They were the ones who made the connections that led to new discoveries. We'll retrace their intellectual journeys, explore their groundbreaking discoveries, and understand how their work continues to illuminate our path forward. For example, the work of Edwin Hubble in the early 20th century provided the first evidence that the universe is expanding, a discovery that has profound implications for our understanding of the cosmos. The discovery of the cosmic microwave background radiation in the 1960s provided further evidence for the Big Bang theory, which describes the origin and evolution of the universe, and understand how their work continues to illuminate our path forward. The discoveries of these pioneering scientists have not only expanded our knowledge of the universe, but they have also inspired new generations of scientists to continue the quest for understanding. Today, scientists are using advanced technologies and techniques to explore the cosmos in ways that were unimaginable just a few decades ago. They are searching for answers to some of the most fundamental questions about the nature of the universe and our place within it. Their stories are not just about science, but about the power of human curiosity, the thrill of exploration, and the boundless capacity of the human mind to grasp the vastness of the cosmos. These scientists were driven by a deep sense of wonder and curiosity about the world around them. They were not content to accept the status quo. They wanted to understand how things worked and why. They were willing to challenge established ideas and take risks in order to uncover new truths. The thrill of exploration and the boundless capacity of the human mind to grasp the vastness of the cosmos. The stories of these pioneering scientists are a testament to the power of human ingenuity and perseverance. They faced many challenges and obstacles in their quest for knowledge, but they never gave up. They were driven by a passion for discovery and a desire to understand the world around them. Their work has not only expanded our knowledge of the universe, but it has also inspired new generations of scientists to continue the quest for understanding. Their legacy is not confined to textbooks or observatories. It's woven into the fabric of our modern world, from the technology we rely on to the very way we perceive our place in the grand scheme of things. The discoveries of these pioneering scientists have had a profound impact on our everyday lives. For example, the development of the theory of electromagnetism in the 19th century led to the invention of technologies such as the telegraph, the telephone, and the radio. The discovery of the structure of DNA in the 20th century revolutionized the field of biology and led to the development of new medical treatments and technologies. It's woven into the fabric of our modern world, from the technology we rely on to the very way we perceive our place in the grand scheme of things. The work of these pioneering scientists has not only expanded our knowledge of the universe, but it has also changed the way we think about our place in it. Their discoveries have challenged our assumptions and forced us to rethink our understanding of the world around us. They have shown us that the universe is far more complex and mysterious than we ever imagined, and that there is still much to learn. So, let's embark on this tribute to the giants on whose shoulders we stand, those who have helped us reach for the stars and illuminated the universe, one extraordinary discovery at a time. As we explore the stories of these pioneering scientists, we will gain a deeper appreciation for their contributions to our understanding of the universe. We will see how their work has shaped the course of scientific discovery and how it continues to inspire new generations of scientists to push the boundaries of knowledge. Those who have helped us reach for the stars and illuminated the universe, one extraordinary discovery at a time. Their stories are a testament to the power of human curiosity and the boundless capacity of the human mind to grasp the vastness of the cosmos. They have shown us that the quest for knowledge is a never-ending journey, and that there is always more to discover. So let us celebrate these pioneering scientists and their remarkable contributions to our understanding of the universe. Let us honor their legacy by continuing to explore, to question, and to seek out new knowledge. For it is through their work that we have come to understand the true nature of the cosmos and our place within it. We stand at a pivotal moment in the history of space exploration, a time of unprecedented technological advancement and scientific ambition. The discoveries of the past century have only deepened our fascination with the cosmos, fueling a burning desire to reach further, to explore new frontiers, and to unravel the universe's remaining mysteries. The future of space exploration is a tapestry woven from bold visions, groundbreaking technologies, and an unquenchable thirst for knowledge. Just as the ancient mariner set sail across uncharted seas driven by a spirit of adventure and discovery, so too are we poised to embark on new voyages of cosmic exploration. But unlike those early explorers, we have at our disposal tools of unimaginable power and precision, telescopes capable of peering back to the dawn of time, spacecraft venturing beyond the familiar planets of our solar system, and rovers traversing the alien landscapes of distant worlds. The next chapter of space exploration won't just be about pushing the boundaries of technology. It'll be about expanding our understanding of the universe and our place within it. We'll search for signs of life beyond Earth, unravel the mysteries of dark matter and dark energy, and perhaps even unlock the secrets of the universe's origins. The cosmos is an endless frontier, and the future of space exploration promises to be a journey of unparalleled excitement and discovery. As we conclude our journey through space and time, let the wonders we've explored linger in your mind. The vastness of the cosmos is a reminder of how small we are, yet how significant our quest for knowledge can be. Each star, each planet, each galaxy holds secrets waiting to be uncovered, and our journey has only scratched the surface of these cosmic mysteries. Remember the unimaginable vastness of the universe, the echo of the Big Bang still resonating through the cosmos, and the intricate dance of celestial objects bound by gravity's invisible hand. The Big Bang, a moment of creation, set forth a chain of events that led to the formation of galaxies, stars, and planets. This cosmic dance continues with galaxies colliding, stars being born and dying, and planets forming in the aftermath. We've journeyed from the fiery hearts of stars to the icy depths of planetary rings, witnessing the incredible diversity of celestial phenomena. Stars, the powerhouses of the universe, forge elements in their cores, elements that make up everything we see around us. Saturn's rings, composed of ice and rock, are a testament to the beauty and complexity of our solar system. We've witnessed the birth and death of celestial titans, and glimpsed the enigmatic realms of black holes and distant galaxies. Supernovae, the explosive deaths of massive stars, scatter elements across the cosmos, seeding future generations of stars and planets. Black holes, with their immense gravitational pull, warp space and time, challenging our understanding of physics. But this journey isn't truly over, it's just the beginning. The cosmos is vast, and our exploration has only just begun. With each new discovery, we uncover more questions, more mysteries to solve. The universe is a never-ending puzzle, and we are just starting to piece it together. The cosmos is a tapestry of endless wonder, and we've only just begun to unravel its intricate threads. Nebulae, the birthplaces of stars, are vast clouds of gas and dust, illuminated by the light of young stars. These stellar nurseries are just one of the many wonders that await our exploration. As we've learned, the pursuit of knowledge is a relay race across generations. Each generation builds upon the discoveries of the previous one, pushing the boundaries of our understanding further. Astronomers and scientists dedicate their lives to unraveling the mysteries of the universe, and their work paves the way for future explorers. The discoveries of today lay the groundwork for even more profound revelations tomorrow. Modern telescopes, with their advanced technology, allow us to see deeper into space than ever before. Each new image, each new piece of data brings us closer to understanding the universe and our place within it. New telescopes will pierce the veil of cosmic dust, revealing secrets hidden for billions of years. The James Webb Space Telescope, with its powerful instruments, will look back in time to the early universe, shedding light on the formation of the first galaxies and stars. These observations will help us understand the evolution of the cosmos and the processes that shaped it. Spacecraft will venture to new frontiers, unlocking the mysteries of our solar system and beyond. Rovers on Mars, probes to the outer planets, and missions to asteroids and comets are just the beginning. Each mission brings us closer to understanding the origins of our solar system and the potential for life on other worlds. Perhaps one day, we'll find evidence of life beyond Earth, answering one of humanity's oldest and most profound questions. The search for exoplanets, planets orbiting other stars, has revealed a diverse array of worlds, some of which may harbor conditions suitable for life. The discovery of even microbial life beyond Earth would have profound implications for our understanding of biology and the uniqueness of life in the universe. But even if we don't, the search itself will illuminate our understanding of the universe and our place within it. The quest to find life beyond Earth drives technological advancements and inspires new generations of scientists and explorers. Each step in this journey, each piece of data, adds to our collective knowledge and brings us closer to answering the fundamental questions of existence. So, keep looking up at the night sky, ask questions, never stop exploring, and never lose your sense of wonder. The night sky, with its countless stars and constellations, has inspired humanity for millennia. From ancient astronomers to modern-day scientists, the quest to understand the cosmos has driven human curiosity and innovation. The universe is vast, mysterious, and endlessly fascinating, and there's always more to discover. Each galaxy, each nebula, each star holds secrets waiting to be uncovered. The more we learn, the more we realize how much there is still to explore. The universe is a treasure trove of knowledge, and our journey to uncover its mysteries is far from over. Thank you for joining me on this cosmic adventure, and may your own exploration of the universe never cease. Whether you're an aspiring astronomer, a curious student, or simply someone who loves to gaze at the stars, remember that the universe is always there, waiting to be explored. Keep asking questions, keep seeking answers, and never lose your sense of wonder. The cosmos is a vast and beautiful place, and our journey through it is just beginning.